Welcome everyone to the fourth and final lecture in Noam Chomsky's lecture series here at UCLA. Before Noam starts, I just wanted to make a couple of brief announcements. First, I wanted to acknowledge the support of the Dean of Humanities and his discretionary fund to help support this visit. I also want to acknowledge two graduate students at UCLA whose idea it was to invite Noam to come and speak to us, and they actually made the initial move to invite him. One of them, I think, is here, Richard Stockwell, wherever you are. Oh, there you are, right, okay. And Nikos Angelopoulos, who unfortunately had to go back to Greece to finish his dissertation. But we'll be taping, we're taping these, and he'll be here in spirit. Finally, I thought I would just share a little piece of trivia that I learned today, and that is that Noam has a bee named after him. Do you know about this? Yeah. It's called, let me get this, Kylie Chomsky. And it was discovered in Texas in 2013. So now you're all in possession of the same trivia. Without further ado, please welcome Noam for his final lecture.
I never did find out whether it's a honeybee with a waggle dance, but I hope somebody will find that out for me. Well, this has been pretty sketchy, especially yesterday. There's lots of loose ends that ought to be tied up. I think it would be best maybe to delay that to the discussion period tomorrow. So I hope you guys will come in with lots of questions and objections, and we'll be able to see if we can fix up what wasn't done properly, of which there's a lot. There was actually one question that came up in the question period yesterday about an important matter, and I didn't actually give the right answer to it, so let me go through it here. If I can get this to work. This one?
Others? Oh yeah, here's the black and the red.
Like
The red might show up a bit better than the green.
Okay.
Try that. If not the black.
Try this. So the paradigmatic example that I was giving about what distinguishes the legitimate from the illegitimate ones, you can illustrate it with parallel merge, the thing that people tend to write like this, where you have set A, B, C, this is the workspace, and then you would join this to this, and that's supposed to give you this thing, which in fact gives you the set A, B, and the set B, C, and this one becomes illegitimate because you can explode this to something as complex as you like, and since this is accessible, you can move that to there. Then you have a chain connecting these two things, which can violate all conceivable properties of language, so that's illegitimate. The argument that it is illegitimate is it adds two instead of one accessible terms, namely this one here and this one here. And you're only allowed to add one in the minimal system of resource control. So the question was, well, why doesn't this block ordinary IM? So suppose you have A, B, and you add this guy over here. Now you have B, A, B, ordinary internal merge. Why can't you do the same thing? Turn this into X, add this up here, and then you get the same problem. If you think about it for a minute, which I didn't when the question was asked, this turns out to be a case of late merge. What you're doing is trying to tack this into something that you've already passed. And that doesn't work for the reasons I discussed last time. Late merge, first of all, adds too many new accessible items, and then it also requires an extra operation of substitution. So it's the worst case of illegitimacy. So that one's out. The difference is once you've passed a certain point in the derivation, you can't go back and do something to what you've passed. But that a problem doesn't arise in the parallel merge case because these two guys are separate and nothing is protecting the thing that you moved from. So that makes the right distinction. Well, there are a lot of other things that need to be clarified, but instead of that, I'd like to turn to something else and at least touch on a few other things briefly, just to bring them up. I won't be able to go into them in sufficient detail. One point is that in addition to the symmetrical operation merge, there's quite good, in fact, I think, completely compelling evidence that we also need another operation, an asymmetric operation, in addition to merge. This is clear intuitively simply from simple adjuncts. So, for example, if you have a phrase like young man, there's an asymmetry between the two that's clear. That element that's formed is a noun phrase, not an adjective phrase. So the old is an adjunct that's not changing the category. Notice this is quite different from symmetrical merge. In symmetrical merge, if you happen to have a head and an XP, then the head will in fact be the label, the thing that traditionally projects. But that's just a case of minimal search, and that doesn't work for adjunct asymmetry. So if you have old portrait of John is not a head, it's complex, could be arbitrarily complex, but it's still the label of the whole unit. So there's a clear asymmetry. Beyond that, there's a problem that's been lingering for 60 years. It's a serious problem. It's the problem of unbounded, unstructured coordination. So if you have something like the guy is young, happy, eager to go to college, tired of wasting his time, endless number of possible adjuncts. There's no structure among them. They're strung together, they're unbounded, and that's a real problem. For one thing, you can't do it in any kind of phrase structure grammar because you'd need an infinite number of rules. That's even true, interestingly, of the universal case, unrestricted rewriting systems, the ones that allow you to do anything, rewrite anything. You'd still need an infinite number of rules. Notice that unrestricted rewriting systems, as was proven by a great mathematician, Emil Post, long ago, are universal. Those are universal Turing machines, in effect, which means you can code the right result by some devious means, but you don't get it by just rewriting the rules and looking at the structure. So that's out totally from phrase structure grammar. About 60 years ago, when George Miller and I were working on mathematical linguistics, we thought we had an answer to this in terms of generalized transformations, but Howard Lasnik pointed out that that doesn't work either, so there's no method around, no device around that allows this. However, it is allowed immediately simply by the device of asymmetric pair merge. What we need is a new device, and since we're trying to get the simplest possible operations, the simplest operation after simple set formation is just pair formation. So we need an operation pair merge, which will also apply to the simple adjunct case, like young man. Young will be adjoined to, will be attached to man, but you don't see it in the labeling, okay, because it's often some other dimension. And the unbounded, unstructured cases show you, in effect, that there are unboundedly many dimensions to what's going on up there. It's not two-dimensional like a blackboard. You can add any number of adjuncts at any point. So we want we want to work this out. That means intuitively that every member of this coordinated construction, every individual member of it is individually predicated of what it links to. Now, we know that the order of the unstructured, unbounded elements, this sequence, we know that the order of it matters. It matters because of reasons that were pointed out by Jim Macaulay about 40 years ago, namely notions like respectively. So if you say John and Bill saw Tom and Mary respectively, the order in which they appear affects the semantic interpretation. So it's not just a set of paired things, it's a sequence of paired things. Furthermore, the more evidence that it's a sequence is that adjuncts can repeat. So you can say the guy is young, tall, happy, young, eager to go to Harvard, so on and so forth. You can repeat them as much as you want. So what we have is a situation where, in order to generate these objects, you generate a set, finite set. You pick out of, you form from that set a sequence, and it could be any sequence of elements, and there's, in fact, infinitely many possible sequences. You pick one out of those, and that sequence, S, call it, is the thing that you're then going to merge into the construction to proceed with the interpretation. This operation of picking a particular element out of the set of sequences is, there's formal ways of doing it which are familiar. Those of you who know some logical recognize that this is David Hilbert's epsilon operator, which picks a single thing out of a set. It was part of his work on foundations of mathematics, basic operation. So it's a straightforward operation, but it does have the property that it's indeterminate. Okay, so it's that's part of the nature of production, as I discussed last time. Well, what this means is actually there's clearly two kinds of coordination, conjunction and disjunction. So what we're doing is forming objects that look like this. We're forming a sequence which begins with some conjunction and then contains a sequence of elements, each of which is predicated of something. So we have things, a sequence of things that look like this with a link. And in fact, we could say L1, Ln, but in fact, all the links have to be identical. One of the aspects of coordination is you're joining everything to the same point. Okay, so we can, and the same with all the ones through. So we have an object like that. That's the basic object that gives you an unbounded coordination. When you get down to just one case, when n equals 1, that's just plain adjunction. So the old young man and so on. Now, notice that each element of these pairs is inaccessible. So if you have the phrase old man, say, you can't extract man and leave old. You can't extract old and leave man. So the elements of the pairs are inaccessible. And if that were all there was to it, notice that this would yield both the coordinate structure and the adjunct island constraint. You have the coordinate structure constraint because every term is inaccessible. You have the adjunct island constraint because you can't pull the things out. However, it's not quite that simple, in fact, as I mentioned earlier a paper by Željko Bosković, which shows that which just reviews lots of different kind of complicated cases. There are languages in which you can extract you can't extract anything inside the adjunct. There are others where you can extract something that's inside but not the adjunct itself, and a couple of other cases. So there's more work to be done. And what it in fact shows is that that the concept of adjunct is just not sufficiently refined. There's a number of different kinds of adjuncts which behave quite differently, and this is in fact kind of an unexplored domain. It hasn't been looked at sufficiently, but here's a major research project, is to ask how can we deal with the class of cases that Bosković left unexplained in his bringing together the two kinds of mysteries. They're still there. So here's a first step in how to capture it, but more has to be said. Well, the next question is, what is L? What do you link things to? So let's take the simplest case, say noun phrase and verb phrase coordination. John, Bill, Tom, the young man, et cetera, read the book, walked to the store, so on and so forth. What's the linking in those cases? Well, the assumption that comes to mind right away is that, say, and incidentally, I should say that I'm going to assume here that nominal phrases are actually NPs. The DP hypothesis, which is widely accepted, was very fruitful, led to a lot of interesting work, but I've never really been convinced of it. I think these things are fundamentally nominal phrases. Actually, there's a very good paper by Masa Oishi, who's here, who kind of spells out how this could work. This would mean that, say, in a nominal phrase, things like definite articles are actually features of the nominal phrase. They're not elements merged into it, very much like Semitic, where it's just a feature of the nominal phrase, and the definite article appears in every element of the nominal phrase, including the determiner. That seems to me probably the way it works. As far as determiners are concerned, like say that, I suspect they're adjuncts. So I'll be assuming that the core system is basically nominal. As I say, Masa's paper spells a lot of this out. So one suggestion you might have is that L is just N, but that runs into an immediate question. If you accept, which I am accepting here, the Chagit Borer, Alec Morant's theory of root categorization, which I think is pretty strongly motivated. You have the roots in the lexicon are independent of category. They become nominal or verbal, adjectival, by virtue of a categorizer that attaches to them. And incidentally, that would surely be pair merged. So pair merges to them, and it's probably it has to be the first operation in forming a derivation. You first attach the root to the category to the root, and you sort of go on from there with a pair merged element. But that element, say N for a root that's going to become nominal can't be identified with the n that is the link here, because this one is just much higher up in the syntactic object that you're constructing. Same with verb. It means that the small v, which is the categorizer, which is linked to the root by pair merge, can't be the same as what we call small v, or small v star, high up in the derivation. And in fact, I think that things like v and v star have been somewhat misinterpreted. They're not really it's not really a verbal categorizer, it's basically a phase marker. And I think we should think of both n, what we've been calling, or what I'm now calling small n, and we used to call small v, as being basically the two kinds of phase markers. I think a kind of natural way of capturing this is to go back to a classical distinction. Actually goes back to classical Greece, which has been used sometimes in generative grammar, and to assume that we really have two fundamental notions. Classical terms, they're the notions substantive and predicative. Which gives you 4 categories, plus S minus P, which is nominal, minus S plus P, which is verbal. And in classical grammars, that's all there is. So if you look at the classical Greek grammars up till late into the Latin, the Roman period, those are the only categories. There's no adjectives. Adjective we can add, but we'll consider it a non-primitive category. It would be both substantive and predicative. And then there's, of course, the fourth one, which is neither. And that's the rest of the junk that's lying around, prepositions and so on and so forth. But the two major categories, the ones that really count, are probably the ones that are the perfect substantive and the perfect predicate, the ones from essentially classical grammar. And there is some, and these are distinct from the categorizers, N and V. Those are totally different notions. And these things then would mark the phases, and it's kind of striking that, and they would be the links. All of these would be the things that coordination, conjunction, disjunction link to. Notice that there's a well-known phenomenon about extraction that holds of both nominal phrases and verbal phrases. There are some nominal and verbal phrases which resist extraction. You can only extract to the edge. You can't go out of the element. So we'll call those strong. In the case of verb phrases, it's the transitive verb phrases, the ones that usually marked V star. Those constitute strong phases that you can't move out of. You've got to first go to the edge, then you can go on. The weak phases, say unaccusatives, passives, you can extract all the way. And there's the same distinction in nominal phrases. So the complex noun phrase constraint, it's been known for a long time. It works strongly for definites, but not for indefinites. It's non-specific and specific. So extraction out of a definite noun phrase violates the rules. Extraction out of an indefinite, non-specific one is pretty straightforward. So it looks like both the nominal and verbal phases have the category, break into the categories, say, strong and weak. What we're calling V and the two types of flavors of V and V star, are probably just strong and weak phase markers, perhaps framed in this system. There is another. There's been a lot of discussion over the years about whether noun phrases are really phases like verb phrases. And one problem about it was that they have a lot of similarities, but there's one notable difference, and that is you don't have an escape hatch in noun phrases. There's nothing that allows you to go to the edge and then go on. But fortunately, as I learned a couple of weeks ago, there's a nice African language called Buli, which does have an escape hatch, has a marker that says, okay, if this is here, we can add on to the noun phrase and then go on. So if we simply assume that the basis for all languages is Semitic, Proto-Semitic, and Buli, then everything works out. So we're off and running. Just have to find the right languages. Other languages, like, say, English, are defective in this respect. They don't have that extra morphological element. It's one of the nice things about doing comparative work. You can fill in the blanks that ought to be there. Well, if you play with this, you'll notice that it can get pretty complicated. So, for example, it could be that one of the conjuncts, say S0, the third element in the sequence, it could, if this is a conjunction, the third one could be a disjunction. Okay, you can stick a disjunction inside a conjunction. And that disjunction could be an unbounded, unstructured element. And if you play with it, it gets very complex. I'll put that aside. The principles for dealing it are straightforward, but the actual working it out becomes pretty hairy. But it's not a fundamental problem, just a technical problem. Now, there is a fundamental problem, which was made very clear by recent work of Barry Shines. I don't know if he's around here somewhere. But Barry has a very terrific book, a great book that every semanticist ought to study carefully, which I think is the longest book with the shortest title in the entire literature. It's the book called And, 600 pages of details about the extreme, intriguing complexities that you get in the semantic interpretation of coordinate structures. It's all done in a kind of an event calculus, Neo-Davidsonian event calculus. So here's the task. The task is to take, assuming that this is the right kind of syntactic formalism, you might play around with it a little, assume that if this is correct, how can you go to from this to those semantic objects, okay? I'll come back later, if there's a little time, to the nature of these semantic objects, but I think he gives good evidence that that's the kind of target that the mapping from syntax to formal semantics is trying to achieve. So here's a huge unsolved problem for those of you who are looking for dissertation topics, one of many. And fortunately, there's lots of such topics hanging around. I should say, incidentally, that this is a dramatic difference from, say, the 1950s and even the 1960s. At that time, it looked like there was almost no topics. It looked like this whole field was finished. I think I mentioned this earlier. And one of the really striking things that's happened during my lifetime is that the field went from one that was terminated to one that's entirely endless and open. Everywhere you look, there's just more problems. That's a good sign that at least something's on the right track, because that's the way things ought to be. You know. People who are just coming into the field now probably aren't struck by the dramatic difference, but if you look back, it really is dramatic. Well, Another case that's an intriguing one is, let's see how to bring this in. Well, that's probably too complicated to go into. I'll skip this. Well, there are lots of other, there are plenty of other candidates for pair merge. Some of them are interesting unsolved problems. So, for example, if you take the paradigm, things like Mary saw the man walking down the street, say, or Mary saw the man walk down the street. You run through that familiar paradigm. You notice that there's a gap, a strange gap in it. With the bare verbs, like Mary saw the man walk down the street, you can't passivize. So you can say, the man was seen walking down the street, but not the man was seen walk down the street. This holds for two categories of verbs, perception verbs and quasi-causative verbs like make or let. You know, so I made the guy walk down the street, but not the guy was made walk down the street. Those two categories. This has been a kind of a funny sort of gap for a long time, no good explanation for it. There is a proposal, an interesting proposal by Norman Richards in terms of his contiguity theory, that it has to do with the output of passivization, but that doesn't work because the same problem arises with in situ passives. So kind of a little awkward in English, normal in most languages, but not bad in English. If you say things like, there were seen walking down the street 3 men, let's say, that's more or less okay. But if you try, there were seen walk down the street 3 men, that's hopeless, okay? So there's a sharp distinction between passives and non-passives, whether or not you move the object. Okay, so that can't be what's involved. So what could be involved? Well, what could be involved is kind of suggested by the fact that this holds for the quasi-causatives, let and make. One might imagine maybe that these things really are just spelling, English style spelling out of causative morphemes, which attach to a verb, which are all over the place. English tends to not use affixes to spell things out as words, but these things could be affixes. So it could be that let and make are just the causative affixes attached to the bare verb. Then comes an interesting question. Why should perception verbs have the same property? But putting that on the shelf, if they all have this property, what you might expect is that all of these are pair-merged to the bare verb. And the pair-merged element is just immune to the passive operation. Say, whatever you think passive is, maybe dropping case, let's say. So that would fill in the gap, making use of the pair-merge device. There are other interesting proposals. One of them is Hisa Kitahara's suggestion about what has always been a pretty serious problem, head raising. Head raising has none of the right properties. It violates the extension condition. It's always described incorrectly. If a verb raises to inflection, say to T, it's always described as if it's a T, but it's not, it's a V. The thing somehow that's adjoined is really verbal, not inflectional. And the further move of V to C is really kind of a V-second phenomenon, not a T-second phenomenon. So there's all kind of problems. Another kind of problem with it is it's sort of, head raising has properties that are kind of shared, that cross syntax and phonology. So it's almost entirely like phonological processes in that it doesn't have semantic consequences. So whether you raise, take Jean-Yves Pollock's analysis of French and English, which many of you know, if you raise, in French, you tend to raise the verb, in English not to raise it, but the semantics doesn't change. If you have a V-second language, it has the same semantic properties as a non-V-second language. And in fact, you have to look very hard, way out at the fringes, to find some kind of semantic consequences to head raising. That makes it look phonological, but the trouble is it's successive cyclic, which makes it look syntactic. So it's kind of problematic all along. But the real question is, how do you get around this? How can you actually create it without violating all the rules? Well, Hissa's proposal is this. Essentially, we'll just take the T to C case, but the same for the others. You generate and then DP. You generate C, then that's just ordinary. It's not even generate. C is in the workspace because that's where the lexicon is. So you just look at it. It's there in the workspace. Then you merge these two, pair merge them. C, T. We now have a set. The workspace now contains this and this. Notice by merging C and T, you haven't increased the number of accessible elements because neither of these is accessible. Okay, that was, as we've already pointed out, they're just like old man, either is accessible. So, and once you've done this, you now simply merge this thing to that. That gives you the right answer. And if you think about it, you can do all the head raising that way. I thought for a while that there were some problems about this. Hissa and I corresponded about it, but I think the problems are easily overcome. So that's a possible way of approaching the entire problem of head raising, which has been a tricky and serious problem. So I'll leave it in your hands to play around with that and see if you can handle the rest of head raising that way. But it's a simple way to proceed, which doesn't violate any of the rules, doesn't add accessible elements, just follows all. It's just available. You don't have to invent anything new for it. And it's crucially has to be pair merge, for one thing, because that's the way these things end up. They end up as adjuncts, not as sets. And secondly, it doesn't add accessible items, so it doesn't violate the resource constraint. So it has the right properties in that respect. Well, there's plenty of questions like this. There's a lot of, a major task that is faced is to take all of the cases that, two tasks. And first one, take the cases that have been described usefully by illegitimate operations. So take all the cases that have been handled by, say, late merge, which is very widely used, or by parallel merge, which gives you all the multidimensionality cases and so on. Now take that whole class of cases and show how you can handle them by legitimate operations. I gave a couple of examples last time, like ATB, parasitic gaps, but do it for the whole slew of them. And of course, the broader task is take a look at that massive data out there and see if you can make some sense out of it. That's we now have a criterion for what make sense means. Make sense means get a genuine explanation, where a genuine explanation means one that's that can be that meets the conditions, the crucial conditions of learnability and evolvability. And if you can reduce it to merge, you've solved that problem, because there's no question of learnability, and the problem of evolvability, as I mentioned, is basically solved. You have to look at the details of how it worked, but we know it happened, okay? So if you can get to that, you have a genuine explanation. If you can reduce things to pair merge, you've come pretty close. You still have to ask the question of how pair merge could have evolved, but at least that's an easier question than lots of other things you can imagine. We would then like to try to show that the other devices that seem critical for explaining things, like, say, phase theory, can be reduced to third factor properties of minimal computation. They do, in fact, reduce computation. So if you could show that that's another third factor condition like resource restriction, you'll have a genuine explanation. That's the general project. But notice it, and it's again clear, should be clearer, going back to my first lecture, that this project only arises if you accept a particular version of what the whole enterprise of linguistics is. If you pick a particular kind of answer to the initial question, what is language? What are we doing? The answer is the enterprise is one that attempts to deal with, to address what I called earlier the Galilean challenge, the challenge that was posed at the beginning of the scientific revolution, which translates in our terms into capturing the basic property of language, the property of that each of the faculty of language permits the generation of an infinite number of structured expressions with semantic interpretations and the option of ancillary operation of mapping it to one or another sensory motor condition. If you accept that project and then a particular variant of that project, which not all people who do generative grammar accept, the second variant is to assume that this is part of natural science, okay? In other words, follow what's called the biolinguistic program. Take this property to be a property of human beings, not some object out in the external world, which somehow magically human beings connect with, but just an actual property of human beings. Then you have to meet the conditions of evolvability and learnability. Then we have the notion of genuine explanation. Then all this mass of questions arises, often with solutions, often not. Notice again that not accepting this enterprise is perfectly legitimate. It's a way of describing things in ways which might be very useful. It's also useful for engineering projects, kind of Silicon Valley linguistics, where you don't really try to explain it, just get something that works. Lots of interesting things you can do. But this is a very specific approach to language, saying it's part of natural science. It's trying to meet the Galilean challenge. If that's the enterprise, then these are the kind of questions that arise. Well, there's another topic that I ought to at least mention. There's not much time for it, which is just left out entirely. A computational system has rules and atoms, things that are the smallest elements of the computation. I mentioned earlier that if you have merge and a one-element lexicon, just one thing in the lexicon, one atom, then in fact internal merge gives you the successor function. And I showed some reasons to think that that's a natural outcome. But in any event, there've got to be atoms. And I haven't said anything about those. So what are the atoms of computation? And right at this point, we're moving to a domain that I really didn't talk about, namely the general domain of semantics. So how does the domain of semantics fit into this enterprise? Well, here you have to be a little careful. You have to ask what you mean by semantics. There's a classical notion, actually goes way back in history, but in the modern period, it's Frege, Charles Sanders Peirce, Tarski, Carnap, Quine, that tradition. This concept of semantics has basically two essential notions. One is the notion truth and reference, which are essentially the same thing. And the other is the notion entailment, with many variants. So let's take a look at those two notions. First of all, the notion entailment is not semantics, it's syntax, okay? It's called logical syntax. Entailment is a matter of the formal relations among expressions. The world doesn't even have to exist, okay? Semantics is the field that tries to relate the internal mental computations to the world, the actual real world out there. That's semantics. That's truth and reference. But entailment is logical syntax. And if you look at what's called formal semantics, which is some of the richest and most exciting work going on in the field in the last couple of decades, notice it's all syntax. It's all pure syntax. And it's an interesting kind of syntax. It's sort of analogous to phonology. If you think about the externalization process, what do we have? The syntax generates a set of objects. We then want to externalize it. And that process of externalization has two steps. The first, it's called, traditionally morphophonemics or phonology, in the sense that, say, Morris Halle and I use the term, but it's the mapping of the syntactic structures to some sort of phonetic form. The phonetic form is a syntactic object, of course, and the mapping is it's a symbolic manipulation. So it's, again, syntax in the general sense. It's a particular part of syntax. I should say that this task of mapping, what generative phonology, mapping syntactic structures to phonetic form, has pretty much been abandoned in modern phonology. Contemporary phonology is mostly optimality theory, and that simply doesn't look at this question, okay? It deals with other questions. But this question of generative phonology, which was in fact the first thing that was discussed back in the late 40s, early 50s, has been pretty much forgotten. But it's there, it's a problem that has to be solved if you are concerned with externalization, with how language gets out there to be sounds or signs. So one task, which is really part of syntax, is generative phonology, mapping syntactic objects to, say, narrow phonetics. Then there's another task, and that is taking the narrow phonetics and telling us how it relates to motions of the articulators or to sound waves, or if you happen to be doing sign, how your gestures end up actually being formed. How do you move your fingers and so on. That's phonetics, acoustic and articulatory phonetics. If you go back to semantics, formal semantics is like phonology. It's syntactic operations setting the stage, you hope, for eventual relation to the outside world. Just as generative phonology is syntactic operations setting the stage for the phonetician to fill in how it relates to moving your articulators around, okay, which gets you to the outside world, something outside language. Well, this then comes the question, notice that of all of the domains of the study of language, it's almost all syntax. It's what we call kind of narrow syntax, just forming the syntactic objects, what I've been talking about the last couple of days. Another part of syntax is generative phonology. Another part of syntax is formal semantics. All of this stuff is going on inside the head, right? Doesn't get to the outside world. It's neither phonetics nor semantics. Of all of these areas, the area of formal semantics is different from the other two in the way it's been pursued, which raises interesting questions. It is the only domain that has not been subjected to the effort to find genuine explanations. So there's no effort within formal semantics to ask, what's the simplest way to do it? The problem is, let's just find a way to do it. You know, if you can get a way to do it by sticking in lots of lambdas and so on and so forth, okay, we'll do it that way. But the question of what's the best way to do it, the way that really gives explanations, that's really hasn't been raised. Now, that's not a criticism. It's a very hard question. And so if it's not been raised, well, hard questions often tend not to be raised. But one should remember that it's a question to be dealt with someday. As formal semantics develops, this branch of syntax develops, it should go the way of generative syntax and generative phonology. In the case of generative phonology, there's a lot of work on how to get the optimal way of doing it. In fact, that's what things like sound pattern of English are about, and plenty of other work. And narrow syntax is kind of stuff we've been talking about. Formal semantics, that part of syntax, the question really hasn't arisen. Sooner or later, it should arise. Another interesting aspect of formal semantics is it's kind of tacitly assumed to be invariant. So if you, there's no proposals that languages have parametric differences in how you interpret, say, quantifiers and variables. There's a way of doing it, and if you do it, that's universal, which is a very reasonable assumption. Because if you think about the things that are being investigated, there's absolutely no empirical evidence for them. A child has no evidence about any of them. So if you look at the literature and you look at the things that people are studying, they're totally without evidence. So either they're just not accurate, or if they're accurate, they're going to be universal. So it does make sense to say that this part of syntax is invariant. I've talked a little about whether narrow syntax is invariant. That's an open question. It doesn't look like it on the surface, but a lot of the work that's been done is kind of restricting the domain of variability of narrow syntax to the point where you might imagine that the core of narrow syntax, what's dealing with the Galilean challenge, the operations that are yielding the semantically interpreted objects, maybe that doesn't vary. That we don't know. It's an open question. If it doesn't vary at all, then the variability of language is entirely an externalization, where it certainly varies all over the map. Not any question there. I mean, it's not free. There's very interesting restrictions, but a lot of variation possible. So that's the kind of picture that seems to be emerging, I think, and it leaves open this thing here. Where does that fit in? How do we relate this stuff that's going on inside the head to the outside world? Turns out not to be such a simple question. In fact, if you look at the proposals in formal semantics, they sound as if they're relating to the outside world, but when you look at them, they're actually not. So it takes, say, model theoretic approaches. The elements of the model are sort of, one treats them as if they're actually out there. But in fact, if you look at the elements of the model, they're completely mental objects. there's nothing in the outside world that corresponds to those postulated objects of the model. So the model theoretic semantics works fine. You know, you can do all kind of things with it, study necessity, you know, so on and so forth, but it's all pure syntax. It's not getting to the outside world. What about event semantics, which is a very rich and productive field, the kind of neo-Davidsonian event semantics? Well, what are events? I mean, are events things in the world? Does the world come packaged in events? Actually, it doesn't. You know, events are our mental constructions imposed on whatever's going on. So events are really internal. And we know that to try to count the number of events that's going on is kind of meaningless. So, for example, thanks to Zeno, we know that if you walk across the room, there's a continuous, the number of events is the power of the continuum, okay, and same with anything else you're looking at. So there are about as many events as you decide to impose. So event semantics, which is very productive and rich, is, again, another form of syntax. So how do we get beyond syntax? Well, we have to look at the notion of reference. Truth will depend on reference. And if we want to look at the notion of reference, we start naturally by looking at the words that purport to refer. So you look at the literature on reference, mostly philosophical literature. Say London is taken to be a prototypical referential word. A lot of problems arise, say Kripke's puzzles of belief, when you try to ask questions about London. But is London a thing in the outside world? Well, you can ask yourself. So, for example, I can tell you that I visited London before it was burned down and rebuilt 20 miles up the Thames. So is there an object in the real world which is physical, because it can be burned down, but then can be rebuilt somewhere else with different physical objects and looking differently? Is there such an object in the physical world, in the outside, in the material world? Certainly not. We could decide to rebuild Carthage, let's say. It was gone a couple thousand years ago. We could rebuild it somewhere else, look different, but it could be Carthage. So whatever these things are, they're not names of things in the outside world. What about other words? Are there, in fact, we might rest the question whether there are any words in language at all that refer to anything in the outside world. I think the answer is there aren't. Some of the reasons for this were given as far back as classical Greece. So, for example, Aristotle asked the question, what is a house? And his answer was, a house consists of the amalgam of two different kinds of elements. In his metaphysics, they're matter and form. So the matter of the house is the timbers, the bricks, the stuff it was made of. The form of the house is the design, what it's for, what the architect had in mind, how it's used, and so on. So something might look physically just like a house, but in fact be something totally different. It could be a library, let's say. It could be a garage, could be a paperweight for a giant, could be all kinds of things. It depends on what the architect had in mind and how it's used and what it's for, basically. But the properties of form are not in the physical world. They're in the mental world. Now, when Aristotle talked about this, this is, from his point of view, metaphysics. In fact, it's in his book, Metaphysics. But when you go to the 17th century again, there was a kind of a cognitive revolution And a lot of these ideas were reinterpreted in terms of modes of cognition, which I think is the right way to look at them. So reinterpreting it in those terms, a house is something that we construct in our minds, which has a material element, but of course the crucial part of it is what Aristotle called the form. That's something that's part of our mental operations. So when we use the word house, we're not referring to an object, and we're carrying out the act of referring, like I'm referring to that object over there, but the word house is not referring, okay? You think about every word in the language, it's exactly the same way. There's an example even earlier than Aristotle, the pre-Socratic example used by Heraclitus, who argued that you can't cross the same river twice, because when you cross it the second time, it's a completely different physical object, and you're a different physical object. So it's impossible to cross the same river twice. Of course, we do cross the same river twice, which simply tells us that our notion river does not refer to anything in the material world. It refers to a construction that we developed. And if you start playing around with how do you individuate these objects, becomes pretty tricky. So for example, take river again, say the Charles River, which I used to cross on the way to work up and back every day in Boston. Suppose you take the Charles River and you reverse the course of the water. It goes the opposite direction. Okay, you've still the Charles River. Suppose you divert it into a different direction, because you don't want it to go into the bay, but somewhere else. Still the Charles River. In fact, you can play around with it and make all sorts of massive changes in the physical object, and it'll still be the Charles River. On the other hand, there are trivial changes that will prevent it from being a river at all. So suppose you put barriers along the side, and you start using it for, say, commercial tankers going up and down. Now it's between 2 points. Then it's a canal. It's not a river anymore. Suppose you even make a more minuscule change. You make what in physics is called a phase change from the liquid to the glassy state. Tiny change, almost undetectable without instruments. But now it has a hard surface. And you paint a line down the middle and you start using it to commute to Boston. Okay, now it's a highway. You've made an almost undetectable change. If you play around with it some more, you can see that you can make huge changes in the physical object. It stays the Charles River. You can make virtually undetectable changes. It's not a river at all. Take a look at any other word in the language, you find it's pretty much the same. So it may be that language simply does not have the concept of truth and reference at all, which means it doesn't have semantics. There is no semantics. There's syntax and there's modes of using the objects you've constructed, roughly what's called pragmatics. It could turn out that the whole study of language reduces to syntax and pragmatics, with syntax having these many different variants. In fact, my guess is that's probably what we're going to find when we pursue the topic further. That raises many very interesting questions. So for example, take these terms like house or river, London, whatever you like. Where do they come from? If we look at animal symbolic systems, a very striking feature of them is that the atoms of these systems, the elements within them, do in fact pick out identifiable physical events. Okay, so you take the bee that has my name attached to it. If it's a honey bee and does the right sorts of things, then it's it does the famous waggle dance. It flies out to a flower, comes back to the hive, waggles, and the things that it's doing are one-to-one identified with particular physical phenomena extraneous to the bee. The distance to the flower, the height of the flower, the orientation in which you have to fly, the quality of the flower, and so on. Every animal system we know is like that. Monkey calls, for example, if there's something we call a warning call, what it means is the leaves are fluttering in a certain way. The monkey reflexively emits some noise. Other monkeys run away. Maybe an eagle's coming, something like that. Animal systems seem to be like this completely. The human systems are not like this at all. That raises a very interesting question. Another one of those mysteries. Where did this come from? And if you look at the array of mysterious things, there are plenty of them, and they fall into a couple of categories, two categories. One category is the category of mysteries where we just can't get the right kind of evidence because it's just empirically impossible for us to do it. We can't go back, say, 200,000 years and hear what people were saying. In principle, yeah, it's an empirically possible. It's a theoretically possible task, but you just can't do it. That's one kind of mystery. But then there's the deeper kinds of mysteries, which have to do with things like selecting the sequence given by the Hilbert epsilon operator when you're trying to form a coordination, or more generally, just picking what sentence you're going to produce. And these kinds of mysteries are the kind where you really don't even have bad ideas. There's no idea as to how to proceed. Those, we could ask what that category of mysteries is like, could mean it's some restriction on human cognitive capacities. A lot of debate about this. Most scientists vigorously reject the idea that there could be a limit on cognitive capacities. But if you think about it, it's a strange position. If humans are similar or part of the organic world, not, say, angels, we ought to have the same properties as other kinds of organisms in some respects. Every organism we know has scope of cognitive capacity and limits of cognitive capacity. And in fact, the two are kind of logically related. Whatever is yielding the scope is also imposing certain limits. And you might ask why humans should be exempt from this. I'll leave that with you as another project.
We're going to have a